Thank you so much for having us here. I'm Felix, one of the engineers here at Google, working on Fastlane as part of the Firebase team.
Hey, I'm Josh. I work on open source software in Firebase, primarily on Fastlane with Felix. And today we're going to be showing you how you can build your own app integrations and make shipping app updates easier and reproducible.
So Josh is going to start with a short introduction on what Fastlane is and how you can use it. And then after his presentation, we're going to do a short live demo on how you can extend Fastlane to fit your needs.
Awesome. OK, so how would you like to have 2 extra hours every single week? Well, our talk is all about saving time and automating tasks so you can spend the time on the things you care about most. So today, I'm going to talk about 3 key issues we as mobile developers face and how we can solve it using Fastlane. I want this talk to be very practice-oriented so that everyone can learn something today and we can start using it. So I'd be willing to bet that you've heard some of these quotes. Brian is the only person who knows how to do a release, and he's on vacation, so we'll have to wait. Or, oh man, our provisioning profiles don't contain the devices we actually need to be using now, so we're going to have to add them, regenerate the profile, redistribute it, and then re-sign the build. Or just, our build is broken. Also, sometimes the marketing team really wants those new screenshots for the app that you've been working on, and that can be pretty tedious. So these are all things that we've heard in the past, and these are not things that we really want to hear. And so that's where Fastlane comes into play. All right, so release day. Super exciting day for all of us. All of your hard work finally pays off. You want to get your app into your users' hands, but there are so many steps involved, right? So first, you thoroughly test your release candidate. And then you take all of the screenshots of all the new features in all the languages and the devices that you support. But then you go to build it, and you run into signing issues. So after you resolve the signing issues, you work on your push certificate if you use notifications. So finally, you upload that new build to iTunes Connect or whatever beta service that you're using. And then you can finally, after that, submit it. This can easily take an entire day. And that's time we as developers have to invest. I'm sure you'd prefer to be working on your app. So that's why Fastlane was built. It's a tool that helps you automate all of these tedious tasks like testing and building and signing and deploying your application. So Fastlane has a bunch of tools that you can use. But we can also combine them with various third-party tools into one workflow. And we can easily automate many parts of our app deployment process with that. As an added bonus, Fastlane is open source and available on GitHub. All right, so what are we really talking about now? It's continuous delivery with mobile apps, but what are the goals here? Well, first off, it should be automatic, like push a button and it takes care of everything for you. And secondly, we want to store as much of that information about the build in version control, and I can't stress this enough. We want the build scripts, we want the build info. This stuff should be in Git, in more version control. This way you have a proper history, and by having everything in one place, it means that you can check out the repo and get started right away. Also, everybody, even new developers on the first day of the job, should be able to build your app. All you have to do is check out the Git repository. And we really don't want to have internal things like wikis pointing to various different documents, describing exactly how we do that. So just keep it in Git. And last, when Brian is on vacation, we still want to be able to deploy that app. So we don't have time to cover everything that Fastlane does. So I'm going to focus on 3 common problems you've probably experienced in the past and how you can solve them using Fastlane. So first off, screenshots. It's a huge pain. And then our favorite topic, I'm sure, code signing and provisioning profiles. And then automation of your deployment process. So every time you publish a new app, you have to generate screenshots and upload those to iTunes Connect. And over time, your app features change. You have new designs, you have new languages, new devices come out. It gets surprisingly difficult to do screenshots correctly. And just to give you an idea, in iOS, if you've got 5 different screenshots for 6 devices and 10 languages, you can easily end up with 300 screenshots that you have to generate locally. And the pain doesn't stop there either. You need to upload that to iTunes Connect and actually place them in the right place. So there's this one tool that we wrote called Snapshot, and we built that to automate the whole process for you. So to use it, you basically just tell Snapshot how to navigate into your app and where to take screenshots. It will then iterate through all the languages, all the devices, and it'll generate those screenshots for you. And finally, it'll collect them into a folder and upload them straight to iTunes Connect using another tool called Deliver. Now, of course, we have the same tool for Android, and that's called Screengrab. It works the same way. It just uses espresso tests, and you can upload all the screenshots through, straight to Google Play using a Fastlane tool called Supply. Okay, so that's really cool, but how does this look in action? Well, if you already have Snapshot set up, all you have to do is enter Fastlane Snapshot in the command line, and Snapshot will automatically detect your project settings and start running UI tests. You can already see the simulator jumping up right here. So what's really cool is that this can run in the background and concurrently, so you can do something else while your computer is generating screenshots for you. And this is extremely useful because it collects all of these screenshots into a folder, which you can then upload to iTunes Connect. And what's really, really nice is that when it's done, it gives you this HTML report where you can see all the screenshots of all the languages and all the devices, so you get a really great overview of how your app looks with all these different combinations. And a lot of companies actually use this to make sure everything looks great, in particular if you support languages like German, which tend to be kind of long on the localizations. Okay, now on to our favorite. We're going to talk about some iOS-specific stuff here. Code signing and provisioning profiles. Whew. I don't know if you remember this dialogue, but it usually signaled the start of an afternoon of code signing troubles. Painful. So now you can press the Fix Issue button here, and sometimes that fixes the issue. But it also had a tendency to break things from time to time. So I want to talk to you about what we can do to simplify code signing so that you don't have the sense of dread whenever somebody mentions provisioning profiles or signing certs ever again. All right, so Apple recommends that when you do code signing, each developer in the team has their own code signing identity, which means that you have one app ID for every app you have, one code signing identity for every engineer in your team, and then you have one provisioning profile for each engineer, or for each app ID, and for each developer. It's confusing. Additionally, for each environment, you have ad hoc, developer, app store. So that means if you have a few developers and a few apps, you can easily end up with hundreds of provisioning profiles and a developer portal that looks kind of like that. It's a little bit of a mess. So when you have this, you have to think about things like, how do we keep the valid profiles in sync? Or whenever we add a new device, how do we make sure everybody gets the right provisioning profiles? And how does onboarding a developer look? And what does her first day of work look like? So this isn't exactly the most ideal setup, and that's why we have a different approach. What if, instead of having hundreds of profiles and certificates for each developer, we share a code signing identity across the entire team? And we use that one identity to deploy to the App Store, and you can store that identity and its private key in a Git repository. You already use Git to sync your source code, so you can use a separate Git repository with your code signing identity in it. And additionally, you can encrypt it, or you can just keep a really secure Git repository. And with this, that's enough to be able to onboard any new developer. Surprise. We've got a tool called Match that implements this workflow. And here's what it looks like. First thing, you just run match init. It's going to ask you for a URL to this Git repository that you want to use. And what's really great about Git repos is that you've got some basic access control here. So you can decide which users have read access and which users have write access. All right, so the first time you run it, you just run match App Store. This will generate a new App Store provisioning profile and certificate, and that was it. Like that's the whole thing. You just have to run this every time you want to run a build on a different machine. And what's really great about this is that you don't need to grant access to the developer portal for all of your developers. You just have to grant access to the Git repository, and that's it. It's nice and simple. All right, so we've covered snapshots and we've covered code signing, but let's talk about why you'd even want to automate deployment. So think about the following situation. Your boss or your project manager asks you for a new build for your clients or for your designer maybe, so you can send that build over so they can check out those latest changes. Okay, so that process looks like this. You go ahead and you bump the version. And then you go and commit that version back and push it up to your repository. You add the new devices to the provisioning profile. You then build, export, and upload. It goes to either iTunes Connect or whatever beta service you're using. And then you add release notes. And finally, you can distribute that. It's a ton of work, but that's where Fastlane comes into play. We can reduce all of this down to just the push of a button. So, first off, Fastlane uses a so-called fast file. And this file contains all the information that is needed to deploy your app. You just define which steps run and in what order, and Fastlane makes sure to execute them. A group of steps is called a lane. And if one of these steps fails, the whole lane will fail. It'll just stop running. And so how does this configuration look for the example we were just talking about here? Okay, well, first you define the lane, and this one is beta. And then you can see the next step is to increment the version number. And then we commit that and push it to our Git repository. And then we use match to ensure that we have the latest provisioning profiles and signing certs directly from that Git repository. And then we use Gym to build and sign. So finally, we're able to upload that IPA to whatever beta distribution service we use, like Fabrics Beta or Hockey app. And after that, we can post a message directly to Slack. So speaking of Slack, we've got many built-in integrations. And I think at this point, it's somewhere around 400. It's kind of changing. But these are things like HipChat and Slack, Crashlytics, Hockey, email actions, Git actions, and so on. If an integration isn't available yet, you can easily extend Fastlane to use your existing shell scripts, Ruby scripts, or you can build your own integration, or even build a plugin that can be shared by many others, which is what Felix is going to be demoing for you shortly. All right, so how does this look in action? Well, that's easy enough. You just call Fastlane Beta. Okay, so another example here. Here we're going to build a new release, and we're going to send it to the App Store. So we run Fastlane iOS release. This will be the first, build. Oh, sorry, here we're actually first signing the build, and as you can see, Fastlane prints out every single command that it's doing. We try to be fully transparent about what we're doing here, and once it's done, it's going to upload the new build to iTunes Connect. And for uploading, Fastlane actually uses a tool that's built into Xcode called iTunes Transporter. And it's done. So if you look at this output, you can see we get this nice little summary table. Actually, it's kind of huge here. But this includes all the parameters that are being used at this point. And it's really, really useful because you can go back into your CI system and see what was being used at any given time. And above that, you can see the commands that were run. And what that means is that if you have any problems and you need to debug this stuff, you can easily go back in, copy and paste, and execute them to see what happens. All right, so that was just a small example of a really useful workflow. Fastlane can help with uploading app metadata and builds to iTunes Connect, managing your push notification profiles, automating app creation in iTunes Connect and the dev portal, testing and syncing your profiles across your team using Git, and much, much more. Many of the tools in Fastlane communicate with Apple in some way. So how does this work? Well, there's no official API, right? Of course not. there's an open source tool called Spaceship, which is part of Fastlane. It takes care of communicating with Apple, and all of our tools are built on top of it, so you know it's battle hardened. And you can use it to build your own workflows. For example, like syncing new LDAP users with the developer portal anytime your company adds a new engineer. So one thing we built that can show you how useful it is to have an API framework is this project we call Boarding. So Boarding is this really cool Ruby on Rails project that gives you a landing page for users that want to beta test your app using TestFlight. And I think that's really cool because you don't have to go into iTunes Connect manually and add people anymore. Originally, this project, Boarding, was just built to demonstrate what you can do with Spaceship, and it only took a weekend to build. Now, lots of people use it, and it's maintained by the community. So feel free to use it with your own apps. You can deploy it on Linux, which is also pretty awesome. It's open source, and you can also find that on GitHub. Okay, so I want to jump back into Fastlane. Some of us using third-party crash reporters, like Crashlytics, have probably run into this problem if we enable bitcode. You build your app, and then you upload it to iTunes Connect. It gets approved and released. At some point, it crashes. So you open up your crash reporter's dashboard, and you note that nothing shows up. You don't see a stack trace. Ah, right. And that's because your app supports bitcode, just as suggested by Apple. Good job. That means they can recompile your app on the fly and generate new DSIMs, which is exactly what happened here. So Apple recompiled your app, and the crash reporting tool doesn't have those new DSIMs. So you got to log into iTunes Connect, find the build, then download the DSIMs, then log into your crash reporter, find where to upload those DSIMs. That's kind of a pain. Well, surprise, we have Fastlane here, and it can get your back. It can take care of that for you. Here, Fastlane will download your DSIMs from Apple, and then it'll upload those DSIMs to Crashlytics or whatever tool you want to use, and then it will clean up after itself. And that's it. That's all of the code. And you can find more information in the Fastlane docs about this at docs.fastlane.tools. And so these are some of the things that you can do with Fastlane out of the box. But let's say you want to build your own integrations with your own APIs. That's where Fastlane plugins come in handy. And for that, I'll hand you off to Felix. There you go, bud.
All right, thanks, Josh. This was a really great introduction of how you can use Fastlane to optimize your app deployment process. And best of all, as Josh already mentioned, all of this is open source, available on GitHub. As you may have noticed, much of Fastlane is highly optimized for iOS developers. But as Josh mentioned, it supports both platforms, iOS and Android. So, all right, let's say you set up Fastlane successfully and you use it to build and deploy your application. But then you decide you want to do something more. Let's say you want to run a code style linter. Let's say you want to run SwiftLint. This is where the Fastlane Docs page comes in handy. We have a list of all the built-in actions over there that you can easily use using Fastlane. Currently, we have about 400 actions available. But what if you want Fastlane to do this one specific thing for your setup, this one thing that is missing? This is where the Fastlane community comes into play, because more than half of the actions that are available are actually provided by the Fastlane community in the form of Fastlane plugins. So just like with the actions, you can find a list of all the available plugins on the docs page, and we make it very easy to find the plugins that are most useful for you. So we introduced the Fastlane plugin scoring system that shows you the popularity of a plugin based on certain metrics, like the number of downloads, the number of active users, the number of contributors, and the number of merged pull requests. And for the distribution for those plugins, we make use of Ruby gems. So this is kind of like CocoaPods, but for Ruby projects. At the same time as Ruby gems, we also make use of Bundler, which allows us to define dependencies in a configuration file and therefore make the build reproducible. And we're going to see a lot more of that in our demo, because every time you want to use Bundler and Ruby gems, you need to prefix a command with bundle exec. So, all right, we want to see all of this in action. We have a sample iOS app that has multiple schemes to choose from. but we don't want to specify the scheme every time manually. We want to define what scheme to use as part of a JSON configuration file. So we don't have to update our Fastlane configuration every single time we want to use the scheme. So this sounds like a great candidate for our first Fastlane plugin. So we're going to build one on stage right now. All right, beautiful. So we are in this demo directory. And inside this demo directory, we have our application called My App. And if we open this up in our text editor, we can see that we have a working Fastlane setup. So inside our Fastlane directory, we have our fast file. And this is a very simple fast file. All it does, it builds our application using Gym, and then it distributes the beta build on Crashlytics. So if we run this now in our terminal, we have to run bundle exec, Fastlane, and then the name of the lane, which in this case is build. So by running this, it will detect our Xcode project, and as mentioned before, we have multiple schemes, and of course Fastlane asks us what scheme we want to run it for. So I'm going to cancel this for now because, as mentioned, we want to have a JSON configuration file. So how can we start a new plugin? Well, let's go back to the root of the demo folder, and I can show you that the git status is clean. We have no changes here for now. And to generate this plugin now, we're going to run bundle exec Fastlane new plugin. And Fastlane makes it very easy for us to build new plugins. So it will ask for the name of our plugin, which we're going to call Parse JSON. It's going to ask us for a description of what this plugin does, parse a JSON file. And it asks us for more information. We're going to provide that later on. All right, what actually happened here? Let's run git status again. We'll see that we have a new directory, which is our plugin. So let's see what's inside this directory. All right, you can see that we have a directory. It's already full of files. It might be a little small to read, but it should be fine. One thing that stands out is that we already have a fast file. But this is not the fast file of our Xcode project. It's the fast file of our plugin. And it already calls Parse JSON. We just created that. So it seems like something already happened there. And since it is a fast file, we can try just running it. So we are inside our plugin, and we're going to run bundle exec Fastlane, and then again, the name of the lane, in this case, it is test. All right, a lot of green text. That's usually a good sign. So we see the short summary of what plugins were successfully loaded. So that is good. And then we see the JSON, the Parse JSON plugin is working. All right, interesting. So something's already happening here. And so when we generated our plugin, it also generated a default implementation. So if we go inside the actual source code of the plugin, we will see that we have the action implementation here. And there's a lot of methods you can implement. Many of them are more advanced, so we're not going to talk too much about them. For example, one method describes what platforms you support, if it's iOS or Android or both. In this case, parsing a JSON works on any platform. Available options we're going to talk about in a bit. Details we don't provide for now. The return value of this plugin is the content of the JSON file. And then as an author name, you can choose to use your GitHub or Twitter username. And here we see the actual message we saw before. The Parse JSON plugin is working. All right, so we need to parse the JSON file, and it is very easy to do that in Ruby. All we have to do is return JSON.parse, and then pass the file contents. To get the file contents, we just call file.read, and we access the file path. And for the path, we're just going to assume a dummy JSON file for now and see if it actually works. So we're going to create a dummy.json file inside our plugin directory. And within that, we want to define the scheme to say demoji custom scheme. This is just a dummy scheme to see if it's actually working. All right, so we define the path, we load the content, we parse the JSON file. Let's actually give this a try. So we're going to run the same command again, Fastlane test. And we see there is some output is missing. There is nothing in between here anymore. So, and the reason for that is that if we look at the example fast file, we call our plugin but we don't use the return value. So we're going to say file contents equals parse JSON, and then to print out something, you just have to do UI.message file content. Let's run it again and see what happens. All right, scheme, the emoji custom scheme. Beautiful. So we are only interested in the scheme. So to access it, we're going to use the square bracket notation. So we're going to say selected scheme equals file content, and then say scheme. And as a message, we're going to say we're going to use the scheme, selected scheme. All right. Let's see if that works as expected. We're going to use the scheme, the emoji custom scheme. All right, so this is all working great. We can parse a JSON file. We get the scheme. One thing we haven't done yet is we don't allow the user of this plugin to choose what JSON file to load. So if we look back, we are assuming dummy.json. And Fastlane makes it very easy to set those values. So in the available app options method, you can just return an array of options you allow to take. And you define the metadata of what kind of values you take. So in this case, we're going to call it path. This is an environment variable we can set, so let's call it parse JSON path. And the description is just like path to that JSON file. And to access it, all we have to do is say params square bracket path. And if we go back to our fast file, we can now pass the path here and then say dummy.json. And this is really important because we don't want people to have to modify their plugin, but we want people to be able to pass values that is working for their setup. So let's run it again and see if it works. All right, it's the same output. We're going to use the scheme, the emoji custom scheme. Beautiful. So we have this in our example fast file. How can we add the plugin to our application? So for that, we're going to go back to our application, my app. And inside my app, we can make use of a command that is bundle exec fastlane add underline plugin. And it's going to ask us what kind of plugin we want to install. So we're going to say it's called parse underline JSON. And what thing Fastlane just found out is that the plugin is not available on RubyGems, which, as I mentioned before, is the system we use to distribute plugins. And obviously, it's not available yet because it's only on my local machine. We just started building it. So we're going to use the local path option, number 2, and it's asking us for the relative path. So we're going to say ... and then the name, Fastlane plugin parse JSON. So it asks us if we can modify our gem file and our plugin file. Again, this is all Bundler doing all the magic for us. It's just, again, Fastlane tries to be as transparent as possible. And let's look at what actually changed. So looking at the git diff, we're going to see that it now attached a new file that is the so-called plugin file. Again, we don't have to understand how this works. Fastlane does that for us, but it is important that you check that into your version control. And so we successfully installed the plugin now, but we don't use it yet. So if we open up the fast file of our application again, we can see that we have our gym call here and our Crashlytics call here. And let's comment these two out for now and focus on selecting a scheme again. So we're going to copy the code we wrote on our example fast file, insert it here, and let's see if it works again. So we're going to use the same configuration. So we're going to run Fastlane and then build. This doesn't look too nice. Big stack trace. All right, let's scroll up and see what happened here. No such file or directory, dummy.json. All right, that looks valid because the dummy.json is in the directory of the plugin, not of our application. Either way, first, before we actually fix the path, we want to fix this error message. We want our plugin to be more user-friendly. And that is really easy in Fastlane also. So as part of the config items, what you can do is you can pass a verify block. And the verify block allows you to define a rule on how to verify that the value is valid. So what we can do is we can say, we can throw an exception using the UI.user error and say, couldn't find given file, unless, of course, the file exists using value. All right. So let's run this again. See how it looks like. Couldn't find given file. All right, this is a lot nicer. Beautiful. So now we're actually going to fix the path in our Fastlane fast file. So to fix it, we're going to go one folder up and say Fastlane Plugin Parse _JSON. The great thing, of course, here is that the JSON file can now be named anything and can come from anywhere. All right, so we were able to successfully load the scheme. So let's connect the things together. We're going to comment out German Crashlytics again. We're going to pass the scheme parameter and select our scheme. And in the dummy.json, we actually want to use the actual scheme. And in this case, for this app, it's called Demoji. So we're doing everything now. Load the file, select the scheme, print out the scheme, build our application, and upload to Crashlytics. Let's see what happens. Same command again. Loaded our plugin. It printed out that it's going to use the scheme Demoji. And these are all these nice little summaries Josh was talking about. So it will show that it is using the scheme Demoji. And then it started building our application. So this is a basic Swift application. So this is going to include the Swift standard library, and it will also code sign our application. Building was successful. We are now uploading to Crashlytics beta. And there we go. Fastlane tools finished successfully. Beautiful. So this all seems like it worked really well. And one last thing we want to do now is we want to publish the plugin to RubyGems. So this looks like it's working well. So we're going to go back to our plugin. And one thing obviously you would do is you would publish the source code on GitHub. In this case, we are not going to do that and only focus on the RubyGems part. And if we go back to our source code, one thing that you need to change is you have to provide a home page. Very often, that's just the GitHub page. So we're going to add my username here. And to now be able to publish the plugin, I recommend running bundle update to make sure you have all the latest dependencies installed. And after doing that, you can run rake build, which will package up your plugin into a zip file. And then to publish this, you can run gem push and then pass the path here. And it's pushing to RubyGems. Successfully registered gem 010. And we can now go to the RubyGems website and search for Fastlane plugin. We will see that we have a lot of plugins here. So currently it's 240 plugins. And depending on how fast their cache is, we can actually find our plugin here. Fastlane plugin Parse JSON released today. All right, we just successfully published the plugin here on stage. So to recap, we just saw how we can use Fastlane in action, how we can change the configuration and change Fastlane to fit our needs. And then at the same time, we were able to prepare it as a package and provide it to other Fastlane users in form of the plugin. And now back to Josh.
Awesome, Felix. So this was a short introduction of what you can do with Fastlane and how it helps save a lot of time during development and deployment. You can find more information on how to get started with Fastlane at docs.fastlane.tools. You can also find us in the Ask Firebase Lounge right after this talk. Thank you.